Hi everyone. Thank you for attending this talk. It's quite intimidating to speak at an international conference like this for the first time, lining up with people who are very famous, much more than me. Before I really start about the content of this talk, I'd like to do something that I think is important and I've seen being done in other contexts and not so much in IT. I'd like to acknowledge the country and pay respect to the traditional owners of the land and pay my respect to the elders, past and present. Thank you. So this is the first slide, and there's some code. That's probably the only code you will see in this presentation. And yeah, that's the only code you can see. I'm here to talk about these kind of problems when you have a view controller that's more than 1,000 lines long. So yeah, if you can't see, it says 1079 here. Yeah, that's the joke. If you don't see what's wrong, or if you think that's okay, I suggest you pay close attention to this talk. I'll be talking about anti-pattern, where there's a class growing too big and you just shove everything in a helper class on the side. Doesn't really help. Problems that is solved many times. Same problem solved many times by different devs on your team. Since iOS 7, we want flat design and like thin lines drawn around views. So you see that crop up everywhere. So we'll be talking about iOS architecture. And before we start, I want to make a point that architecture is not a one size fits all. It depends on your context, on the goals of your project, the client you're working for, the company you're working with. Goals maybe can include reuse of some of your code, consistency of your code base, readability or maintainability of your code, focus on test coverage. These are the goals, and they are part of the context of your projects, and that will dictate what kind of architecture you will use in your project. So I will give you my learnings from the point of view of a tech lead on a project and working with Outware for a big client. I'll be introducing VIPER quickly and talk about a real life use of VIPER on a specific project that I worked on recently, and the learnings that we got from that as a team and as an individual. So first, even before we talk about VIPER, let's talk about clean architecture. So that was first introduced by Uncle Bob. And the point of clean architecture is to say that the architecture of your project should make the intent of your code visible and obvious. If I tell you that I wrote an app in VIPER, it doesn't tell you what my app does. So in that sense, VIPER is not an architecture. It's just a design pattern that gives you a framework to build a better architecture for your project. The goals of clean architecture, according to Uncle Bob, are to make your project and your code independent from any frameworks that you have to choose, any UI choices, any database choices, basically anything that is external to your code. And also make your code more testable. So VIPER is an application of Uncle Bob's clean architecture principles, and it gives you a detailed framework on how to organize your project to achieve a better architecture, a clean architecture. So it all started with, for us at Outware, with an article on Objective-C.io. So if you don't know Objective-C.io, it's a website with a lot of articles about OS X development, iOS development. And it was an issue about a year and a half ago, issue number 13, about architecture, which mainly talked about MVVM and how to better organize your projects and your code. And we read about MVVM. If you don't know MVVM, it stands for Model View Model. It's a design pattern to help you organize your code towards presentation logic and view logic. And there was one last article about VIPER, and we liked the normative approach of VIPER, the clear separations between the layers, And in the rest of this talk, I'll probably mention this article many times because that was the only piece of documentation we had at the time. So I'll call that the founding article or the article. So in this article, you can see a kind of marketing-y kind of diagram of what is VIPER. So the layers that I mentioned earlier, VIPER means view, interactor, presenter, entity, routing. It's not really important for the sake to go really into the details of that. Maybe one thing that is important is that VIPER was called VIPER as a backronym. Initially, what they really came up with first was the separation between view, interactor, and presenter. So it's just to say that don't think that you're doing VIPER wrong if you don't have all of those five layers in your module or in your app. It's just a way to put it in a nicely packaged name. A slightly more technical diagram. Again, it's not really important to pay too much attention to that. It's just to give you a sense of scale. So VIPER speaks about use cases or modules. It's most of the time it's one screen. Here you can see, for example, that wireframe. I've never talked about wireframe before. It's just different naming for router. So it's not really important. Just to have a sense of scale it's not one VIPER thingy, whatever it is for your whole app. The granularity is one module, one use case, one screen. Those words are kind of interchangeable in this presentation. So when we read about VIPER, the appeal of VIPER for us was the use of ponzos, and they may even have coined the term. So ponzos are very simple objects that they use to communicate data between the layers. They're a bit like the view model in MVVM, so you can see there's a bit of similarities. And they're simple objects, so simple enough you can test them very quickly, very easily. There's a similar concept in a talk by Brian Geziak from Facebook at UIConf 2015, where he talks about parameter objects, where that's a bit similar. I won't spend too much time on that. Those ponzos, those simple objects, are good candidates to be made immutable. So if you're writing in Swift, that's maybe probably a good place to start using structs and make your objects reduce the state of your app. VIPER also enforces decoupling between the layers by using a dependency inversion principle. So what it means is that the view, the presenter, and the interactor don't talk to each other namely. They just talk to an interface. So the interactor doesn't know that it's talking to a view controller. So it means you could potentially swap layers and implementations. And it makes your code a bit more reusable. And finally, one thing that maybe is a bit overlooked is the router. So we all know presentation logic, business logic, what it means in an app. But routing logic I think is a bit of a novel idea, at least it was to me. And it kind of makes sense in iOS. And I like to see the router as a programmatic equivalent to the storyboard when you draw the floor of your app between your screens. So the router is the layer that kind of say what screen comes after another. So that's really the bullet points of why we liked VIPER and what was novel and interesting about this new approach. So the real life use, it's using VIPER on a reasonably big enterprise project. What I mean by reasonably big is more than 10 devs for more than 8 months. So I don't know how that scales to the projects you guys are using. For me, with my experience, that was a rather big project. That's a lot of code over a lot of time. And as I said earlier, architecture is dependent on your context and your goals. So when I mention Project F, it's the project I worked on, our goals were maintainability. So the client wants to build on this app for the next few years. So we need to ensure that they can maintain the code and keep adding features and it doesn't become a mess. To achieve that, we want to have a good consistency of the code base. And obviously, we want to have a good code coverage. So those were the goals that we were trying to achieve. And So the benefits of using VIPER during this project were to have those view, interactor, presenter, entity, router kind of layers separate clearly where your logic goes. It helps enforce the separation of concerns. And most of the time when a dev would doubt a bit on how to approach a problem and they didn't know where to put some new logic, during tech huddles or during morning stand-ups, another dev of the team in the team would ask them, oh, do you think it's a presentation logic or a business logic? And just this kind of approach gives you an idea that when you know where things go, it helps organize your code in a more clear way. It seems a bit like a cookie cutter approach where all you see as a dev is presentation logic and business logic. It's a bit simplistic, but most of the time for an iOS app, which is very interaction-driven, UI interaction-driven, that helps solve the issue of where to put something. And if there's no clear answer, if it's not presentation logic or business logic, then you know that it shouldn't be in this VIPER module. Maybe it's app domain level kind of logic, or it's maintenance job or something. So you know that it shouldn't be in a VIPER module because it doesn't belong there. So it still gives you a good approach. So that's an example of how a VIPER module, that's a sample app that we developed at Outware just to learn about VIPER and teach ourselves about VIPER. So that's a classic to-do app. So that's to see the detail of a to-do item. So here you can see the separation between the layers, what goes where. Another positive aspect of using VIPER was by having those clear-cut approach, your classes end up doing less. So your files are shorter and straight to the point. On Project F, so a big enterprise project, we didn't have any file bigger than 450 lines of code. So when I was joking about 1,000-line view controller, that's some things we've all seen in a lot of projects. After 8 months, not having a file bigger than 450 lines of code is, I think, a good achievement. And on average, there was only like 3 files that are bigger than 400 lines. Most of them were under that. The average was 60 lines of code. There's a caveat to that. I'll mention a bit. I'll touch about this later. Obviously, if your classes are smaller, your code does less. Your test cases do less. Your test cases are easier to write. They resort to less exotic trickeries and stubs. And the barrier to entry for any developer to write tests is lower. So it means that your devs want to write tests. They feel it feels like less of a pain. On Project F, we used a BDD approach, and we used Kiwi. So it meant we had short, behavior-driven tests that could be almost used as a developer documentation. So when a dev would maintain a module or extend a module because there's a new feature to add to an existing module, they can read the test cases. They understand what is expected. They understand what it's supposed to do. Instead of having a huge monolithic test case, they can understand before they break it or before they extend it. They know what it's supposed to do. And that's a good point when you can start leveraging your tests for developer and understanding the developer documentation and understanding the features. Obviously, this kind of approach also helps consistency. It means that all modules look the same. Any developer can pick up any module that they didn't write first, and they can understand what's going on and how to maintain it. You don't need to learn the local convention or why you did this thing in that way in this part of the code. You already know it. You feel right at home on any module. If the product owner wants to change some rule, you go look in the interactor and you know what to change. If the tester report that some date doesn't format properly, you go see in your presenter, for example. So those are, I think, huge advantages, not only for big projects, but any project can see that those points are really good. There's some things that didn't work, so let's talk about what were more of a hindrance of using VIPER. So those are the things that we didn't find a solution at the time, or we didn't find a solution even now. We're still wondering how we could fix these kind of things. So verbosity. That's the #1 complaint about VIPER within my team was, as I said, we have smaller files, but there's a caveat is that this logic doesn't vanish. If you have smaller files, it means you have more files. And VIPER uses protocols, as I said, interfaces to talk between layers. So it means you have a lot of files to deal with. So even for a simple module, you have up to 10 files, sometimes even more. And for a simple module, those files are very empty, very, very small, and they just like proxy calls to each other. And you touch something, it goes through the presenter, goes to the interactor, and then come back to the view controller. And it seems a bit like an overhead. And because Xcode is not so good at jumping to a definition of something that is declared in a protocol, it makes the whole experience of navigating your code not very enjoyable. At the time on Project F, we wanted to learn VIPER. We said, okay, let's stick to it. Let's learn even if it hurts, and it hurt a bit sometimes, especially on these kind of aspects. But then it raised the question: how do you decide if a module is too simple, if a use case is too simple, and what do you get away with? Like, should we just start with a view controller because we have to? It's UIKit, and we dump everything in the view controller, and as soon as it grows bigger, we start pulling it into a tractor presenter. But who does that job, and who's in charge of the refactoring? And it just felt like it was delaying the problem later and making it someone else's problem. So even to this day, I don't really know how to find a slider where you could say this is a simple use case, so we should just have an interactor. This is a complex use case, we should have a fully fledged VIPER stack. If you've had the same problems using VIPER, I'd be happy to hear about your experience, because that's something I still don't know how to solve. I cheated a bit when I showed you the example before. This is actually what a module would look like, even a simple module. So that's 15 files here, and this is only for a to-do detail. So it's just to present the detail. It's just a screen with some bunch of text and a few images to show you a to-do item. So it seems like it's a lot of files for little logic. Developer onboarding. That was our first mistake, because we played with VIPER at Outware before starting Project F. And some people gained some experience, we developed this sample project that I showed you earlier. And when we started Project F, we had a bunch of new people coming, and we thought, okay, we'll give them the articles that we read, and if they have any questions, they can ask us. And you know, it never works like this. So it's a new paradigm, it's a new design pattern, so it takes time for people to get used to it. And on Project F, on average, we've seen that it took people about 3 weeks to not feel lost anymore, where they really don't understand, oh, what's an interactor? I don't know what to do with the presenter thing that lays here. And it takes on average a month and a half for people to feel confident and contribute design and architecture suggestions to a technical, for example. Again, that's relative to the size of your code base, but that's something you need to consider. On the flip side, you could say that a developer already knowing VIPER would have onboarded on this project much faster than any other developer on a regular project, because if you have a project with no clear architecture, then they have to learn whatever local convention you have here. But I have no evidence that would work, because I only worked on VIPER on this project, and nobody knew VIPER around me at the time. Developer engagement. That's something we completely overlooked. We didn't even think that could have been a thing. Most developers were open and curious, so that's good. But after a little while, some of them started voicing their dislike about VIPER. And the point here is, I think the architecture of your project and the design pattern that you choose to follow is a technical choice. So you need to explain that to your team. And we didn't think that when we decided to go with VIPER on this project, we didn't think that people wouldn't be excited about trying something new. But some people just don't want to, and that's fine. But you need to explain why you're doing this, what are the goals you're trying to achieve, and those goals can seem arbitrary maybe to your team members. Let's talk about easy improvements. So those things that I mentioned before are things that we didn't know how to solve at the time. those things, what I call easy improvements, is small problems that we can easily, next time that we're going to use VIPER on a project, we know that we need to think about those details first. Naming convention, all those classes and protocols and all of those things that I mentioned before, how do you name them? You choose a sensible naming convention with your team, and you stick to it, and you enforce it. How do you enforce it? Why not during code reviews, or during tech huddles, or morning stand-ups, whatever. But just choose a bloody naming convention and stick to it. That makes everyone's life easier. Dogma. What I mean by that is, when we started on this project, we said, all right, it's going to be a VIPER project, and we'll stick to it. And because we didn't know any better, we thought, okay, everything is VIPER. As you say, when all you have is a hammer, everything looks like a nail, right? So now it seems obvious to you, maybe, but if you're building a UI component, it doesn't need to be a VIPER module. It doesn't even need to be a module at all. If you are building a UI component, you might as well make it look almost like a UI kit component, because everything else looks like a UI kit component. And it kind of come back to the point about verbosity, where how do you know where to use VIPER and where not to use VIPER? What are the limits? How do you use it properly? And we decided to go with VIPER until proven wrong. And UI components are at least one point I can clearly say we were proven wrong. So that's how we use VIPER on this project. What we learned with all of this is that a lot of people read VIPER and they're like, oh, what are all those new names I don't know about? I've never heard of this before. And maybe they are a bit taken aback by this. And if you actually take the time to play with it and try it in a project, maybe just at a small scale, and you make it your own, and maybe you'll realize that this is equivalent to this. And it seems much more familiar now. It's not as catchy, it's not as easy to pronounce, but it looks much more familiar. The point is that I don't think that VIPER is VIPER registered trademark, anything. It's just a different take on existing best practices. It's an attempt at porting them for iOS development to give us a framework that's a bit more strict, a bit more normative than the default MVC. Because a lot of people probably think about MVC, oh, you create a new Xcode project, you create a new bunch of files. I'm doing MVC. It says view controller, right? Apple uses MVC in their framework, but it doesn't mean that just by using Apple technologies, you're doing MVC right. And it's good that Xcode or Apple or anyone doesn't forces you to full MVC. So we can use VIPER, or we can use MVVM, or we can use whatever architecture you want to use in your project. But by not giving you clear guidelines, if you don't follow any guidelines, then you end up with this other MVC that I have to mention. It's the second time today it's mentioned, but I think Tom mentioned it before as well. I think design patterns should be prescriptive. It should prevent you from doing stupid things, but at the same time guide you and show you how to do things in a better way. And also be flexible for this one edge case that no one thought about until it's 2 hours before ship time. It should help you make the small choices up front. How do you name this? How do you solve this problem? How do you organize this thing? You choose that early on. You make it a convention for your team, for your company, for your project, for whatever. You don't have to stick forever. You don't have to think that VIPER is the one true way to do everything. So quickly on the facts, what VIPER helped us achieve: 80% test coverage, and by that I mean everything considered. More than 5,000 test cases, no file bigger than 450 lines. It wouldn't be honest to attribute all of this to VIPER. What VIPER did is that it forced us to think about architecture design. It made it the central point of all the discussions we had. How can we make the architecture better in this project? I think that's interesting because that's what engineers like, is to build good things. The same way Apple say that the best thing about this MacBook Pro is that inside is also it looks good. For us, when we ship something, if we know the code is well organized and well architected, it feels good. The epilogue, I'll try and go very quickly over this. I So after this project, I transitioned to a new project where I was the only iOS dev, much smaller team. So again, different context, different goals. And I thought, which architecture should I follow? And obviously, I spent more than 8 months with VIPER, so it was heavily influenced by VIPER. And so I chose to base my new architecture around a router that would do a lot of things. It makes sense for this project because we were using RESTful APIs and the routing was driven by the server. The point is that VIPER was not a means to an end. It's not like, oh, I found VIPER, I'm going to stick with VIPER until I die because that's great. It helped me see what was poor in our previous architecture. It helped me see one way of solving it and where are the pain points. So VIPER was a means to an end. It was not just a final product. It helped me care about architecture more. I mentioned tech huddles, code reviews. When we think about design patterns, we think about code. We think about Xcode project and how to put a class here or there. But you need to think that we're still humans pushing the buttons on the keyboard. And if your design pattern relies heavily on naming, then you need to have people in your team communicating to communicate those new naming conventions and how they apply them. If it relies on consistency, maybe you want to have senior devs pairing with junior devs to tell them how we used to do things so it's more consistent over time. So the process and the design pattern work hand in hand, I think, and it's important to realize that. And when you choose a design pattern, it means that maybe you'll need to adapt your processes. Tooling, I recently finally wrote some Xcode templates, and I wonder why I didn't do that earlier. If you have a VIPER stack with 10 files, and each dev, when they create a new module, they need to create 10 files by hand, it's annoying. Nobody wants to do that. If you spend a bit of time on adapting your tooling, probably it will help people adopt and understand your design pattern better. I cannot mention VIPER without mentioning who invented them. And thanking Sarah Lincoln for using her artwork in the first few slides. All the talks I mentioned earlier, this is the cheat sheet if you want to take a snapshot of that, if you're interested in this material. Or you can just go grab the slides at this address. So that's me, that's Jean-Etienne, that's 12 characters, including hyphen and an accent, and that's just my first name. So it's a bit difficult to register on Australian web forms. They don't accept hyphens or accents. So you can call me Jet. I'm at Jean-Etienne on Twitter if you want to read all the boring stuff and all the code that I yet have to contribute on GitHub. I work at Outware. We are hiring, and if you're interested in writing clean code and developing interesting projects, come talk to me. Do we have any spare time for questions? No, I spoke too much. I'm sorry. Thank you.